start? Hello friends, good evening. I am Deepak again welcoming you at the personal tutor, and today I am giving the lecture regarding the optical communication. And before starting the lecture, I would like to introduce about the basic definition of the optical communication, and is that optical communication is the stream of communication where the transmitter can send the data in the form of the optical light, and as it is, the receiver can receive the data. So the optical communication it's again have the two system. This is called the transmitter TX and the receiver RX. As the wired media, if I want to communicate with the transmitter to receiver, now I required to connect it through the some physical media. As in the traditional communication system, we were using the copper wire and the twisted pair. Now, to use the capacity of the channel, I am using the optical fiber because it has the capacity in the gigahertz. Now this is the optical fiber. Cable which is connecting the transmitter and the receiving node. Now, as we all know, the light travels in a straight path. It can move in the several miles, or can say it can cover the several miles. I'm taking a very good example of the optical light propagation is the sun. As per my knowledge, the sun ray reaches on the earth and it takes the time 8 minutes. It travels in a straight path and cover the various layers of the atmosphere. Troposphere, ionosphere are the such of the instance of the atmospheric layer. But according to the principal laws of the reflection and the refraction, the rays reflect back and the refract back according to the medium. So now I am introducing the two principles, the reflection and second one is the refraction. Sometimes in our daily routine we observe some shiny surface. The surface are shiny because the optical lights are reflecting back to it, and we can, and in other example, we can view some object because the light is again reflecting through that object. So the reflection is the process where if the optical light is coming through one medium, it will reflect back on the same medium. This is called the reflection. But what happened in the refraction? In the refraction, if the ray is coming from one medium, suppose the ray is coming from the denser medium or the lighter medium, and it is moving through the rare medium or the denser medium, so it will move toward the normal or it will move from away the normal. This is the diagram A, which is showing the reflection, and these are the diagrams of the B, which is showing the refraction. If the question arises, if there is no object or the obstacle is occurring on the path of the optical light, what happens? So it will travel in a straight path, just like. So now this principle we will use in optical communication, and before starting the optical communication, I would like to introduce the optical source. What kind of the source we can use for the optical communication? So here I am using the two kind of the source. That is my headline is the optical source. Source, what is the source? Source is the generation of the data. The mean which generate the data, it's called the source. So in optical communication, we have two sources. The first one is the LED. It stands for the light emitting diode. That is the light emitting diode. And the second source is laser. L A S E R, and it stands for light amplification by stimulated emission of radiation. I'm again repeating, laser. Laser stands for light amplification by stimulated emission of radiation. Now we will cover the principle of the generation of the optical light via these sources. So we have to understand these sources individually. So here I am covering first of all the LED. So it's a light emitting diode. There are the two kinds of the diodes. The first one is the normal PN junction diode, and the second one is the LED. Now I would like to put the lights on both of this. The PN junction diode is used for the conduction of the currents, and these are the normal Zener diode, tunnel diode, Schottky diode, varactor diode, or can say the varicap diode, or the normal PN junction diode. which conducts the current either in the forward biased, either in the reverse bias. But LED is a light emitting diode which conducts the light. So here I am making the diagram of the LED, and these are the P and N junction which works on the forward biased, and if I am passing the current through the P-N junction diode, it generates the light just like from the junction. So now I am going the detailed study of this P-N junction diode and how the LED works. So before starting this, I would like to put the lights on the three process. The first one is making the diagram. This is diagram A, this is diagram B, and this is diagram C. This is the process of the absorption. The first process is the absorption, and the second process is the spontaneous emission. Second one is the spontaneous emission, and the next is the stimulated emission. Now, what is the differences of these three processes? As we all know, if we are study of the electrons or the atoms or the molecules, so we all know whenever electrons absorb the energy, so it comes on the valence band, and if again it's absorbed the energy, it's move or escape from valence band to the conduction band. In the short description, I am representing the two states of an electron, that is the VB, valence band, and the conduction band. Again, valence band and the conduction band, valence band and the conduction band. Now, suppose our electron is at the lowermost shell of the valence band. My electron is at the valence band, and if I am providing the energy to this electron via mean of the external energy, or this energy may be the photonic energy, current, voltage, or the heat energy. So if I am providing some external mean of the energy to this electron, the electron will move from valence band to the conduction band, and it will create the hole in that place. मेरा जो इलेक्ट्रॉन था वो वैलेंस बैंड से कंडक्शन बैंड में मूव कर गया आफ्टर एब्जॉर्बिंग द सम एनर्जी. What happens if the electron reaches on the conduction band? So the answer is that whenever electrons reaches at the conduction band, so after completion of the 10⁻⁻⁸ second, After completion of the 10 to the power minus 8 second, it reaches again on the valence band. तो जैसे ही मेरा ये टाइम पीरियड कंप्लीट होगा, मेरा इलेक्ट्रॉन फिर से कंडक्शन बैंड से वैलेंस बैंड की तरफ क्या होगा, मूव करेगा, और यहां पे जो होल है मेरा, उससे क्या करेगा, ये recombine हो जाएगा. So guys, you have to remember the two process. The first one is the electron hole pair generation, and second one is the electron hole recombination. So please, dear students, read the two process: the electron hole pair generation and the electron hole recombination. So here I am covering my topic, so I am not going with the detailed study of the electron hole generation and electron hole pair recombination. So this is the electron hole recombination, and do always remember, whenever electron and holes recombined, it's generate the energy. It's generate the energy in the form of the two energies. The first one is in the form of the h nu, or the second form is the heat energy. Do remember, guys, this is the very important thing. Whenever electron and holes get recombined, it's generate the energy. It's generate the energy in the form of the either light or either heat. So now I am asking the question, if you observe, whenever electronic gadgets get charged, generally it dissipates the heats. It dissipates the heats. इसको स्टॉप कर दो.